Hi guys, I hope you all are doing well. So today we'll be starting with our fourth chapter of mathematics, class 10 mathematics, that is quadratic equations. I hope you have practiced the third chapter that we have seen in the last video, that was pair of linear equations in two variables. Okay, so let's get started with our fourth chapter, that is quadratic equations. So basically this chapter is related to our chapter 2 that we studied in the last video, that was polynomials. So, what is the reference of polynomials over here, and what are quadratic equations? Why they are called as quadratic equations, and what are the examples? How do we find the roots of the equation or solutions of the quadratic equations? This is all that we are. What are the nature of the roots? What is the nature of the roots? So this is all we'll be learning in this chapter. So let's begin with the chapter. So basically, in the Chapter 2, Polynomials, we have learned a form of equation that was written in the form as ax square plus bx plus c, right? So this was a polynomial because and this was a polynomial of degree 2, right? Because the highest power of the highest power of x in the equation is 2, right? So this is how we find the degree of the we find the degree of the polynomial. So we know that this is a polynomial and its degree is 2. What if we equate this polynomial with 0, then this whole thing becomes a quadratic equation. So basically, if we equate a degree 2 polynomial with 0, then it becomes a quadratic equation. I hope this is clear. So here also in the PDF, we can see that when we equate this polynomial to 0, we get a quadratic equation. Quadratic equations come up when we deal with many real life let's say, situations. You will go through many examples in this chapter that will deal with real life situations where we need to use polynomials. So moving further, we'll see what are quadratic equations. The quadratic equation is a quadratic equation in the variable x is an equation of the form ax square plus bx plus c, where a, b, c are real numbers. For example, 2x square plus x minus c and it is equal to 0. Okay. One more thing we need to understand over here is a cannot be 0, because if a becomes 0, then this whole term becomes 0 and we are left with only a degree 1 polynomial. And if we equate it with 0, we do not get a quadratic equation. For a quadratic equation to exist, the equation should have a degree 2, like we need to have x square anywhere. It may happen that we don't have the term bx, but that is okay, but we need to have a term ax square, and a, b, c needs to be a real number. I hope this is clear. Okay, cool. So moving further, I hope you have understood the concept of quadratic equations and what are quadratic equations. We are given with n number of examples, that is 2x square plus x minus 300. Here we can see that here a is equal to 2, b is equal to 1, and c is equal to minus 300. Right. Okay. There are also many examples where 2x square minus 3x plus 1 is equal to 0, 4x minus 3x square plus 2 equal to 0. Here you can see that it is in the form of bx minus ax square plus c is equal to 0. That's okay, because we can bx plus ax square, because we can say that a is minus 3. So that is not the problem, but it should exist. The term x square with any of the coefficient should exist. So basically, two conditions that a, b, c are real numbers and a is not equal to 0. I hope this is clear. So again, If we write all the terms in the descending order of their degrees in a polynomial, we get the standard form of equation, that is ax square plus bx plus c is equal to 0, where a is not equal to 0. This is the standard form of the quadratic equation. So if you are given with a question where they have given some calculations, maybe they have given two brackets including x, then you have to solve it, and they have asked that is it a quadratic equation. The only thing you need to remember is that it satisfies that you can compare the equation with the standard form of the quadratic equation, that is ax square plus bx plus c, and a is not equal to 0. That is the only condition we need to check whether a given polynomial is a quadratic equation or not. I hope this is clear. Cool. So we are given here that check whether the following are quadratic equation or not. So let us solve one of the example. Um, we'll take example 3. So if we expand example 3, if we multiply the x into this bracket, we get 2x square plus 3x is equal to x square plus 1. So we need to make 0 to the LHS or RHS anywhere. So I'll just shift the whole right hand side part to the left hand side part. So 2x square plus 3x minus x square minus 1 equal to 0. So that is equal to, so that is equal to 2x square minus x square, we get x square. We get x square plus 3x minus 1. So we can see that we can compare with the standard form of equation, that is ax square plus bx plus c. We have a, we have b, we have c, and a is not equal to 0 for this equation. So therefore, this polynomial is a quadratic equation, hence satisfied. We can check the answer as well. X square plus 3x minus 1. It is a form ax square plus bx plus c. So the given equation is quadratic equation. Cool. Moving further, we have exercise 4.1. Again, that is a self-study part. You can do it on your own. If you have any doubts, you can put it in the comment section. I'll definitely clarify them. Moving further, we have a concept called as solution of quadratic equation by factorization. So basically, if I take a value, let's say 6x square plus 4x plus 1 equal to 0. You know that as the equation has a degree 2, so therefore there are gonna be two values of x, such that let's call them alpha and beta, for which this equation is satisfied. So basically, if I put the values of alpha and beta in x for this equation, they'll be equal to 0, or this satisfy the equation. Therefore, a and b are called as solutions or roots of the quadratic equation. We can see over here also. We can say in general a real number alpha is called a root of the quadratic equation if they have substituted alpha in the place of x. If this is satisfied, we also say that x is equal to alpha is a solution of the quadratic equation, or alpha satisfies the quadratic equation. Anything you can say. So therefore, the zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c are the same. So basically, roots and zeros are one and the same thing. So we don't have to worry about what we call uh, root or zero. That is one and the same thing. So basically, as it is a quadratic equation, we'll be having two roots for the equation. So let's say we have alpha, we have beta. In general, we say that we have alpha and beta. Now let us try to understand that how do we find the roots of the equation using the method of factorization. Let's take this example, 2x square minus 5x plus 3. Yeah. right, 2x square minus 5x plus 3. Right. So basically, we need to find two such values of two numerical values of x such that they both satisfy this equation. I hope that is understood. How are we going to do that? So we will use the method of factorization. So method of factorization is a thing that we need to split the middle term. It is also known as splitting the middle term method, I guess. So we need to split the middle term such that the like let's say we have the term bx. We need to split the middle term such bx such that its product or its difference or sorry, the its addition or subtraction is equal to bx only with its sign, including the sign, and its product is equal to and the bx is equal to the product of a and c. So basically we need to split bx as that the product bx is equal to the product of a and c. You can see over here, because we need so basically, let's say we have this term 5x. Let's say we have minus 5x. So basically we need to split 5x in two values, let's say p and q, px and qx, right? So basically if we add or subtract whatever operation we perform, if we add or subtract, if we do p of x plus minus q of x, we should get minus 5x. And if we multiply p of x and q of x, sorry, if we multiply uh, p and q, we should get a into c. So basically this is how we are going to perform the splitting the middle term. This is how we are gonna go. We are going to split the term middle term. So basically let's write our equation again: 2x square minus 5x plus 3 equal to 0. So this you are going to split the middle term using trial and error method. You need to imagine those values that can give the product 2 into 3, that is 6, and minus 5 as your sum or difference. Okay. So okay, now we want to split the middle term, right? Uh, right. So how are we going to do this? And if I take 2 and 3, okay, if I take 2 and 3, if we add them, 2 plus 3 is equal to 5, right? But 2 plus 3 is equal to 5, and we want 2 into 3, and we are getting also 6. So basically, if I split this into 2 and 3, so I am getting the product as well, that is equal to 6, and I am also getting 5. But how we are going to do that? If I just add them, I'll get 5. But I need minus 5, so therefore we cannot take just 2 and 3. And if we subtract it, so we'll not get the value. If we subtract 2 minus 3, we'll get minus 1. So this is also rejected. So how can we do that? One thing that can be done is to split the middle term into minus 2 and minus 3. So basically, if we write it as minus 2 and minus 2x and minus 3x, and also multiply the same. So minus 2 into minus 3 is equal to 6. So therefore both the conditions are satisfied, and therefore we can split the middle term as minus 2x and minus 3x. So therefore we are going to write it as 2x square minus 2x minus 3x plus 6 equal to 0. I hope this is clear. Now, now as we have split the middle term, we are going to take some of the numbers common, and then we'll solve further. So I can see that I'll just change the color of my pen. I'll take it yellow, orange. Okay. Now we are going to take some terms common from these both terms. Okay. So from 2x square minus 2x, I can see that we can take 2x common. If I take 2x common, I am left with x, because 2x into x gives us first term, that is 2x square. And here we are left with 1 because 2x into minus 1 gives us minus 2x. I hope this is clear. One hack that we can use it over here. Whatever bracket we have written over here now, we can write it over here again. Okay. Now we have to write some we have to put some sign over here and one number over here. So if we so when we open the bracket, we get these two numbers, right? Now I can see that here I have minus sign and I need minus 3. So basically I need minus 3x and I have over here okay, wait. I think we are mistaken. It's okay, so yeah. Oh, one mistake that I have done is here it was 3 and not 6. It was done by mistake. Okay, cool. So basically, I want something to be written over here. Over here that gives when we open the bracket that will give us minus 3x plus 3. So if I write minus 3 over here and if I try to open the bracket, I'll get minus 3 into x, that is minus 3x, and minus 3 into minus 1, that is plus 3. So therefore, we have taken something common out from both the terms. So basically, I have got one bracket. So what we are going to do, so what we are going to do is to take this one bracket and one bracket from these two terms, that is 2x and minus 3. So basically, what we'll do is x minus 1 and 2x minus 3 equal to 0. So now I have got two brackets that are into multiplication is equal to 0. So basically that means that one of the brackets is 0 or both can be 0, right? And we know that degree is 2. So both are going to be 0. So there will be two cases, case 1, case 2, where x minus 1 equal to 0, equate first bracket with 0, then equate second bracket with 0. So therefore from here you get x is equal to 1 and from here you get x is equal to 3 by 2. This is a very simple calculation. I hope you can do it on your own. So basically we have got two values of x such that it holds true for the equation, that is x is equal to 1 or x is equal to 3 by 2. If we try to substitute it in the equation, our equation was 2x square minus 5x plus 3 equal to 0. If we put 1 in the equation, we get 2 into 1 minus 5 into 1 plus 3 equal to 0. 2 minus 5 is minus 3. Minus 3 plus 3 equal to 0, right? If we put 3 by 2, 2 to 3 by 2 whole square minus 5 into 3 by 2 plus 3 equal to 0. So therefore 2 into 3 by 4, sorry, 9 by 4 minus 15 by 2 plus 3 equal to 0. So 2 into 9 is 18. Sorry, I'll just cut it over here. So 9 upon 2 minus 15 upon 2 plus 3 equal to 0. ठीक है? So 9 minus 15 upon 2. 9 minus 15 is 6. Minus 6 upon 2. Minus 6 upon 2 plus 3 equal to 0. And if I divide this, minus 3 plus 3 equal to 0. Hence, we have got the root of the equation, that is x is equal to 1, comma 3 by 2. I hope you have understood the method of splitting the middle term. You can see over here, we have x is equal to 3 by 2 or x is equal to 1. And we can verify them again, right? So, right. Note that we have found the roots of 2x square minus 5 plus 3 by factorizing into two linear factors and equating each factor with 0. We have just split the quadratic term into two linear factors and then we have equated that factor with 0 individually and then we have got the value of x, the values of x. I hope that this is clear. So next up we have exercise 4.2. You can solve it on your own. Okay, now one more thing that we need to find out is nature of roots. like the roots are equal, the roots are real, they are not real, something like that. One thing that you need to understand is this we can also find, this is also another method to find the roots of the equation. Bit lengthy or maybe calculative, but one and the same thing. You can use this uh, method also. Here we write d is equal to discriminant, and discriminant is equal to b square minus 4ac. So basically you need to equate your equation with this, compare your equation with this standard equation of quadratic equation, and then you need to get the value of a, b and c with the signs. Okay, and then x is given by minus b plus minus root b square minus 4ac upon 2a. So basically one root is minus b plus root b square minus 4ac upon 2a, and one root is minus b square of minus 4ac upon 2a. You can see over here we have written minus plus minus. So one root, for one root we'll use plus, and for one root we'll use minus. I hope that is clear. Okay, so what are the nature of the roots? Firstly, we'll find the discriminant, that is b square upon 4ac. Before finding the roots, we can identify what type of roots we are going to get. That is using the discriminant. B square minus 4ac is the discriminant. If the discriminant is greater than 0, then we'll get two distinct real roots. Basically, we'll get two distinct real roots. Uh, Two values of roots we'll get, they'll not be equal, and we'll get distinct real roots also. So let's say alpha and beta will get if b square minus 4ac is greater than 0. That is this part, under root के अंदर वाला part is greater than 0, then we'll get two distinct real roots. Cool? Yes. Next, we have if b square is minus 4ac equal to 0. If this part over here becomes 0, we are left with minus b upon 2a only, right? So basically, for both the roots, we'll get same. So for so both we'll get same roots, right? So therefore, x is equal to minus b upon 2a plus minus 0. So that will not make any difference. Therefore, x is equal to minus b upon 2a and minus b upon 2a. So therefore, when a discriminant is equal to 0, then we'll get two equal roots. So the roots of the equation are both minus b upon 2a. So therefore, two equal real roots are present in this situation. Okay. Next is if b square minus 4ac is less than 0, that is it is negative. Abhi, you imagine that if there is negative number inside the root, how are you going to find it out? You learn complex numbers in class 11. That is not here. That is not for your grade as of now. So therefore, you just need to remember that if b square minus 4ac is less than 0, that is if it is negative, then no real roots are acquired. We get imaginary roots. So therefore, no real roots for the given quadratic equation in this case. Just we'll quickly summarize. If the discriminant is greater than 0, then we get two distinct real roots. If b square minus 4ac is equal to 0, then we get two equal real roots. And if b square minus 4ac is less than 0, then we get no real roots. I hope this is clear. Here in the example, we are given that find the discriminant of the quadratic equation 2x square minus 4x plus 3 equal to 0, and hence find the nature of its roots. So basically, we can see that here a is equal to 2, b is equal to minus 4, and c is equal to plus 3, right? So if we find the discriminant, that is b square minus 4ac, okay? If we find b square minus 4ac, that is minus 4 square minus 4 into AC, that is 2 into 3. We get minus 8. Now minus 8 is less than 0 because it is a negative number. Minus 8 is less than 0. So therefore we get no real roots. Okay, the equation has no real roots. I hope this is clear. There are more examples and exercise 4.3 that you can solve it on your own. So yeah, we are done with all the concepts of this chapter. We'll just quickly summarize what we have learned in today's video. We have learned that a quadratic equation in the variable x is the form of ax square plus bx plus c, where a, b, c are real and a is not equal to 0. Okay. A real number alpha is said to be a root of quadratic equation ax square plus bx plus c if it satisfies the equation, and it is also called as the root of the quadratic equation. Therefore, the root and the zeros are one and the same thing. ठीक है. If we factorize ax square plus bx plus c into a product of two linear factors, then the roots of the quadratic equation are can be found by equating each factor to zero. So basically, we are splitting the quadratic equation into two linear factors of that quadratic equation, and then we are just equating it with zero individually, and then we get two values of x for the quadratic equation. Next up, also we have a quadratic formula, that is plus minus b square minus 4ac upon 2a. Provided that b square minus 4ac is greater than zero, we can use this formula over here. Then we have learned the nature of roots. If the discriminant is greater than 0, then we have two distinct real roots. If discriminant is equal to 0, then we have two equal roots. So basically value will be alpha only. Similarly say 1, 1. Okay. And if we have no real roots, when we have b square minus 4ac, that is discriminant is less than 0. I hope you have understood all the concepts, and this was a very small and easy peasy lemon squeezy chapter. So I hope you have all understood the all the concepts, and practice well. Go through the textbook once. Go through the solved examples. Practice the exercise questions, and then I'll see you in the next video. Thank you so much for watching this video. Take care. Bye bye. Have a good day.
वीडियोस बनाने हैं, फिल्मोरा है ना.